Omega Optics developed an innovative phased array antenna under a 2007 NASA SBIR Phase 2 contract. A phased array is an array of antennas in which the relative phases of the respective signals feeding the antennas are varied in such a way that the effective radiation pattern of the array is reinforced in a desired direction and suppressed in undesired directions. What is a flexible phased array antenna? And why solution processing technique such as inkjet? Because conventional PAAs are on rigid substrates and do not conform well to non-planar surfaces. Integration on exploration vehicular surfaces such as the Orion would require some kind of conformality. One method could be to fabricate chips separately and then integrate all components, including antenna elements, on a flexible substrate such as canvas. However, the process is labor-intensive and the devices are unreliable. Using a solution processing technique, it is possible to incorporate the full functionality of a PAA on a lightweight, low-cost, flexible substrate directly in a minimum time. How are such circuits made? Using an inkjet printer. Different components forming the full PAA, including transmission lines, switching elements, active part, antenna elements, are all fabricated using inkjet printing. Once formed, another passivation layer with interconnection lines is used for final packaging. The fabricated devices are then tested for quality and then are ready for deployment. The circuit can flex and bend and can be integrated with an astronaut suit or on the vehicle directly. The circuit can be rolled and transported, lightweight and small form factor. At the destination, the circuit can be unrolled and it's ready to be used. For the ones integrated on suits or vehicle body, they can also be used to send transmission. The phase shifter consists of several switches whose on or off states determine whether or not the radio frequency signal passes through the arms connected to them. Each arm has a different specified length of transmission line. Therefore, depending on the switch selection, the RF signal can pass through a different length of transmission line and hence attain a phase shift. This switch selection can be performed for all the phase shifters connected to all other antenna elements. By appropriately selecting the switches of all phase shifters, it's possible to obtain a phase shift profile across the antenna elements. This leads to constructive and destructive interference of RF signal, leading to strong buildup of RF energy in a particular direction. Now, by choosing a different switch configuration, this angle of maximum can be changed, beam steering. These circuits are low cost and are disposable as required.